So this is a talk that I like to do about the consistent way to do ingestion frameworks and data engineering best practices while using not by any means new tool, Databricks, but definitely something that's newer on the landscape for those of you that have been doing traditional data engineering for a while now. This might be something that if you haven't started playing around with is something that your organization might really benefit from. And we'll talk about how it fits. So a little bit about me. I'm a technical director at Captech. I've been there for over 15 years, specializing in SQL Server and Azure data platforms. I got an MCSE a while back on SQL Server. I talked to a lot of SQL user groups, but then also in the Richmond area to just different technology organizations. I went to the University of Richmond, got a computer science degree, and also went to UVA, where I got a master's in IT management, and I started my own baseball data analytics company. So today we're going to be looking at some of our example processing with JSON files coming from the MLB Stats API. And so if you are interested in baseball, you will get a little more benefit out of this. And if you hate baseball, I apologize. There's some stuff you can reach out to me after the presentation with any questions. I will send a PDF version of the slides also to David that he can distribute. So today we're going to talk about modern data architectures briefly, and then specifically data lakes and design patterns for how they fit into the organization, so that we can talk about how Databricks is the compute piece on top of a data lake. We're then going to do a deep dive into the tool itself to talk over what it is and what it's capable of. I do have a lot of code to show, so that's going to be much more exciting, but I have to get through the business talk stuff first, but then we'll wrap up with framework best practices and some key takeaways that I really want to make sure everybody goes home with. So try to provide you good tools you can start using. So if you have been doing data engineering in Azure, these services will look pretty familiar to you. I just want to highlight the ones we're going to talk about today so you can see like mentally where we're sitting. On the left side are our storage services and for data. On the right side are our compute ones. Today we're going to talk about the second storage one, which is Azure Data Lake. That is a Hadoop compatible scalable storage for big data workloads. It is meant to be done with large data sets. It is also meant to be done with files as opposed to traditional databases where you think in terms of rows and columns being built into an MDF on the background. This is built on Azure Storage using the hierarchical namespace that exposes folders. So it looks like your traditional Windows Explorer structure, and you can have lots of different types of files, but typically the files that are exposed for querying are in what's called Parquet file format or some sort of compressed format. Sometimes they're in Avro. But today we're going to talk about Parquet files in Data Lake. And on the right side, we're going to talk specifically about Databricks, which is an Apache Spark-based analytic platform for data exploration and feature engineering with Elastic Node clusters. So the big part of processing big data in the cloud is the separation of compute and storage. So unlike a traditional on-premise SQL Server, where it's a big beefy box that has hard drive and memory that does both, and it's really on one unit, and you can add hardware as you need, we're decoupling that in the cloud, and we're putting all of our data in the data lake, and then we're going to process it on demand with Databricks, so that we're going to have a thing called clusters that we can spin up and scale as needed, and then we're going to write Apache compatible, Apache Spark compatible languages to process that data. The cool thing is you can turn the clusters off when you're not using them, and then the storage persists. These other components are key in a modern data landscape. So really what we're going to be talking about today is a traditional analytic flow for big data going to the purposes of BI. So while machine learning and data science and doing data services are really important, we're not going to really talk about that use case for Databricks today. We're going to talk more about traditional data engineering, where we have a variety of sources that we've ingested via Data Factory in our case, but there's also Azure Functions and Event Hubs for streaming. We're going to store that data in a data lake. We're going to process it with Databricks. You could potentially serve that back out to a SQL database or a Cosmos database. You could use Synapse to do both. But what we're going to do today is actually show data warehousing in Databricks itself. So that might be referred to as a lakehouse style, where a lot of clients we're seeing today will let the data lake service serve both traditional source system data lakes and also the analytic data warehouse. And then we're going to hook those up to consumption services to be able to serve out the information. So Power BI has a Databricks plugin. You can drop right into the Parquet files and actually pull the data through Databricks out to Power BI dashboards, which is pretty cool. Different talk. I'm not going to do that today, but something I've done and it is fun. So when we talk about data lakes, this is really trying to solve the problem that organizations face about having disparate source data. So the lake is a place to centralize all your source system data and process it as near real time as is necessary, but also to keep transaction as current as possible. So this idea that we need to basically do incremental loads to the data lake where we source the data maybe every day. We look for the changes that are since the last time we ingested, and then we process those and merge them into the target. It's important that we maintain our data integrity and we do deltas, but not a lot of transformations. The real value of the lake is that it looks a lot like the source system, but it's all in one place and we can start linking things together to find information and insights and then do our traditional ETL style ingestion to a data warehouse. When we set up the data lake, we really want to think about zones. So there's lots of different names. Some people refer to bronze, silver, gold. Some people like to use the word curated. I'm very flexible on that, but conceptually, I like the idea of a raw zone, which is data stored in its native format. So it might be a CSV file, a text file, a JSON file. Really, we have data that has some sort of structure, but it can be unstructured as well if you know how to process it. But then we go to a valid zone or a curated zone, which is the source data with all the transactions applied and the deltas, I mean, and it's going to be in that Parquet format. So this is where we're going to originate some of our queries. Typically, we don't let the users query raw. We start them at valid. And then refined is where you might put your data warehouse or your analytically driven tables, where you've already processed the data for speed. It's imperative for data lineage to keep track of data as it progresses through the zones. And then it's important to understand your data formats and your access policies. So something called RBACs or ACLs are two different ways to manage who has access to what services in Azure. And then ACLs is who has the permission to do the read, write, execute on the files. So as you start spinning up this data lake service and having security issues, it's important to think about data governance so that you don't turn your lake into a swamp. You want to think about data formats. And then the consumption methods of like who needs to access what at what times and how frequently. That matters for the Databricks cluster sizing you're going to do. So as we think about cluster sizing, we can talk about compute isolation. We can scale those as needed. You can have very small Databricks clusters to do little workloads. You can have big beefy ones that do your massive once a day transactional loads. It's important to think about schema when you think about your Databricks data lake processing. Some of it you'll know ahead of time, but some of it you won't. So JSON files are great, but they also don't have enforced structural integrity. So you might end up with more dynamic schema and doing schema on read. So as we think about data lakes, the real benefit that organizations get out of them is that advanced analytic capability where we can perform experiments. We can create predictive work products, and we can also gain business insights by looking into trends. The benefit here is, unlike traditional Teradata or SQL Server warehouses, we could do really big queries across a lot of data, but the performance took a hit and it was expensive to have really performant systems to look at all your history. The benefit of the cloud, obviously, is the ability to add and use hardware with a much more minimal cost, and we can actually get to years over years of data much more quickly. So I'll stop there. Any questions on lakes, general architecture principles before I jump into Databricks details? This is one more diagram. What we're going to talk about today, I want to focus on the right side. What we're doing is we are assuming that Data Factory has already used a data catalog to grab some information, loaded it to the raw zone of our lake, and then we're going to pick it up with Databricks to process it into the valid zone. And then eventually valid can go over to that refined zone. So that's the difference, is that Databricks is really allowing us to move the data between our data lake zones, which is also pictured over on the middle left, going between. When we talk about Databricks, it is a PaaS service offering, so that's platform as a service.
Cameron,
Yep.
You have a question. Let me. Go ahead, Nick. You can ask your question.
Hi. Can we? Sorry, I joined a little late. Back to that the architecture diagram, the big data architecture. I guess second slide.
This one?
Yeah, here. Okay, yes. So, I mean, you have an injection here, and then you have a prep and train where you have used the data break. So the purpose of having a data break is to kind of, process the data, curate the data, and maybe, put it into the target. So, I mean, can't we do the same functionality using the, data factory or probably the Synapse analytics?
You can definitely do it with Synapse. This slide isn't, I need to modify that. Synapse logo on the bottom should really kind of be between both, and Databricks can really be between both too. I was thinking about this before the presentation today that I didn't love the way this looked after I made it. Really think about Databricks as the way that it's accessing the big data storages. Synapse can totally do that as well. It's not meant to be a one or the other. It's not meant to be that they can't both do it. The storage and serving is what's a little bit different. I would offer, simply from a cost standpoint, that there was benefits to shipping prepped and trained data out to a more persistently available storage service. So you might do a small Synapse instance that does data warehousing, a fact dimensional model more traditionally, and you might dump it to a SQL database that would be available to Power BI and data services. You're shipping data twice, which isn't great, but it's just a different design pattern to what you want to allocate cost and clusters to. So if you had data services with real-time data investigations happening from an API or a mobile app, if you're hitting Databricks directly to get to the cloud storage, to the data lake storage, then you're going to pay for that cluster all the time. So there's just an option to ship it to a more serviceable layer, if you will. Whereas the experimentation and the processing could happen in Databricks.
Okay.
But my scenario today, we're going to model and serve out of Databricks as well, or out of the lake through Databricks as well. Yes, you could also hook things directly into your Parquet files. Just know that that's a read-only thing and that you wouldn't want to process transactions directly to the Parquet. You can do that with Data Factory. I've had much limited success maintaining my data integrity doing that because you don't get the benefits of what we're going to talk about right now, which is the Delta Lake framework is a big component of Databricks. What they've done is they basically took the idea of a Parquet file and made it a functional database. When David and I started working together on projects using Databricks, this wasn't available and we had to figure out how to do it manually. And it was interesting. David got it to work, but once we got Delta Lake, it was amazing how much easier it was, where you can just do insert and update and delete commands against a Hive metastore table. So put a pin in that. We're going to go back to the beginning of this slide, which is the languages it supports are Python, Scala, R, Java, and SQL. Important to note that they are the Spark flavors of those languages. So there are some nuanced differences, but generally speaking, those libraries are natively available on the Databricks side. You have the ability to create tables over your files in the data lake and also views over both tables and files in the data lake. And Databricks stores those in what's called the Hive metastore, where it keeps track of what you have structured for your entities so that they're queryable when a cluster is running. It also has a built-in DBFS file system where you can also store information, and it does a lot of processing in memory as well. So it's just important to note there's a little bit of separation there. The schema is maintained in the Parquet file. The objects are maintained in the DBFS system. So again, we're talking about separating storage from compute, where the data remains and the cost is reduced. I mentioned clusters. There's a link on the slide that talks more about what clusters are. We are today talking about my implementation of Azure Databricks, though Databricks is also available over in AWS land and in GCP land. So with Azure, we're again focused on data lake storage and Synapse being integration points. With AWS, it is natively integrated with S3 and Glue. And with GCP, you get BigQuery and Looker. So if you work on one of those other cloud providers, this is still very much applicable and valuable. I don't believe there's huge differences. It's just for my purposes today, I'm doing it on Azure. So what does Databricks give you over native Spark? Just a little history. Databricks was started by the folks that basically created the Apache Spark framework, and they open sourced it, but then they wanted to make money and offer more infrastructure as a service on their own. So creating a PaaS offering. So they are a for-profit company, but they do contribute code to the open source community, which brings me to the Delta Lake thing. Like I said, that's the ability to have these tables that allow for CRUD operations on your Parquet files. They actually open source that as well. And so you can use the Delta IO without having to pay for the full Databricks PaaS offering, which is great and nice of them to do. But I really like using the Databricks tool because it gives me all that infrastructure service that I don't have to manage. Databricks also recently released something called Delta Live Tables. The link is there. It got released just in late April. I haven't had a chance to use it, though. There's a card on my current project backlog to do a demo with that for them soon. So I'm going to be learning it. You might want to look into that. It's also a way to accelerate ETL development. I think it probably does a lot of the things I'm going to demo for you under the hood on its own. So I've ended up building a lot of these things for clients thinking we needed them. And I bet you they just exposed their own flavor of it at this point. So Databricks to button up is for business use cases of developing lakehouses and performing advanced analytics and processing the data that makes it through the zones of your data lake.
We had one question, Cameron. BG asked, are there Azure components like Synapse, et cetera, that can consume Delta tables?
Yes, I'm pretty sure. Specifically Synapse, and I know there is integration, like I said, with Data Factory to the Delta Lake tables as well. I haven't tried it out other than it worked with like the Parquet files where it can do the writes. So if you envision like event-driven stuff or web click data, you could have new Parquet files coming in and dropping them into the Delta Lake, and it would make them available. I haven't tried to do it with merges yet, so that might be possible, but I've used Databricks to do all that thus far.
Yeah, I think BJ, in general, a lot of the providers are using or are providing connectors to Delta Lake now because it's an open format and it's pretty popular, I guess, in the Databricks world. So like even Snowflake has a Delta Lake connector and a lot of the other tools as well. So it's increasing popularity.
Right. So it's a great point. You don't have to use Databricks to do this, but that's the point of my talk. So I'm endorsing it for the purposes of it's what I'm talking about today. But so we'll go from there. So in my data lake, I can show you through Azure Storage Explorer. I have
one more.
Sorry,
there's one more question I did want to
no, go ahead.
Go over top. Nick, go ahead.
Yeah, I mean, you mentioned that we can create the table also on top of the data lake files, tables in view. And where can we see that structure though? I mean, if it is like, Databricks is just the processing engine using the Spark cluster. So where tables and view gets created then? So
that's it. It's created in the Hive meta store, and Brandon and David might actually be able to answer better than I can beyond that. But if you see, so my cluster is running. So this is the Databricks Workspace. We're going to talk about some of the features of what you're seeing on the screen right now. But if you go to the data blade, you'll see the exposed databases, and you can see that I have a lot of them. You would notice that I don't necessarily have all these same databases in my Azure Storage Explorer structure, because this is the folders that I've set up in my lake, and these are the databases I've exposed. So these databases live in the Hive metastore, but reference locations in my lake. So each of these databases has a series of tables, and then I can pick. So this is Stats API. This is going to be my valid demo area today. And so these are all the tables that I'm exposing out of my MLB JSON files. So you can actually click on the game table. One thing that's not great here is views and tables look the same, but they're basically all just exposed as queryable entities. Databricks itself doesn't seem to give you an icon or descriptor. So what this says here is database name, table name, and it gives you a little bit of metadata. So you can add descriptions. It tells you how many files there are and the size. This is the schema. So these are the names of the columns that I have defined in this table, and you can see the data types. These are mostly strings, but here's some Booleans down the way. It inferred these for me when I created my data frames on top of the JSON files and to put them in here. So it actually declares how we get the names. I'm going to show you, but it declares the schema and creates it for you if you do it on the fly. And then it actually gives you some sample data so you can actually scroll through and see what some of the things look like. And it has some sorting capabilities, which are pretty cool. And then we're going to show how if you look at JSON structures, you can actually explode them out too. So to answer your question, this is what I was saying, where you can only look at the tables and databases and schemas if a cluster is running, but that information is made available from the Hive metastore.
Oh, so this is a part of the Databricks cluster itself.
I think it's reading it from the Parquets, but it stores the locations in the HDFS that you've procured for yourself.
No. What I'm saying is the metadata of this, I mean, it is showing this table and view as a metadata. Actual, the file gets stored into the data lake, and it's just referencing here. So that Hive layer, it's inbuilt with the Databricks cluster when we spin up the Databricks cluster.
Yes.
Oh.
So other features of the Databricks Workspace itself, you have this Workspace blade, but you have a somewhat new repos capability. Databricks has long had Git integration that was kind of terrible to work with, but it's gotten much better. So I have a repo here. I have it connected to DevOps. I have branching, and I have a repository called DBX training, and you can see I've got some files and then some folders and then folders within files. And all I can click on this master branch. I develop a master because it's my own thing. Obviously, you would do feature branching for your own development at your organization. So it does code differentials for things that I've changed, and you can add commit messages and dump them just like you would expect a good IDE experience to have. It's got recents. But then we just walked through the data blade. There's also the compute blade, which shows you your clusters. And so this is my cluster that I'm running. It tells you the runtime and then how much memory and cores. And then this is all configurable. You can delete the cluster entirely, which I wouldn't recommend. I like to keep my clusters available, but you can stop the cluster, which stops the clock running on the Azure cost. If you click on it, you get a little bit more information, and there's tons of stuff under here that I'm not going to show. You also have some settings that you can make personal to you, and then some administrative things for the workspace if you have the right privileges. But for our purposes today, we're going to focus on looking at notebooks. So this is a SQL notebook. It tells you you're allowed to have notebooks of any of the different types that Databricks supports. So if I click on new notebook, I get to choose my language. So these are the 4 that I mentioned. And so a notebook is of one and only one type, but you can actually switch between languages between the different cells. So this is the cell within a notebook. And so that cell has to have one and only one language, but I could actually switch it to Python if I wanted to and run a query. So if you're a SQL Server developer, you're going to get like nice reserved word coloring. It's going to look like a SSMS interface. So what I did was I actually just said, hey, I've got a file in the raw zone of my data lake. I'm going to query it. I'm a data analyst. I'm trying to do data engineering. I have the permissions to do queries on raw, even though that's not something you want to open up to your broader user community. So I'm trying to develop a pipeline. And so what this is a flat file called batter war, which is every hitter over history and what their WAR was, which is wins above replacement for every season. So big data set. It gives me the first 1,000 when I do a select star by default. You can get all if you need. But the first thing that stinks is that when you query a raw CSV file, it doesn't give you the fact that this header row is here and available to you. So that's already kind of disappointing. But if we switch over to Python, So this is a Python notebook, and it's all the same commands, just scripted differently. Of course, I changed something at the last minute and didn't test. So if I do header row to true and I tell it that's going to identify the quotes and I display out the output of that Spark read command, you can see I get the same data set that we had before, but this time it gave me the headers as the top row. So that's cool. I get the ability to do that. If we switch back over to SQL, I'm going to go look at a JSON file. So this is, again, going straight to my raw zone of my lake and looking in the given Stats API folder. I've stored a data set called team. I've partitioned that folder by season. So season equals 2022. And I'm looking at file 108, just a random one of them. This is for the Los Angeles Angels of Anaheim. They have one JSON file per team in the teams folder. You can see Databricks actually exposes this structure as an array of one element, and then you can click on that and you can see your attributes of your JSON and the key value pairs. So what's interesting is that we have nested structure here. So as a data engineer who doesn't know this schema, and my goal is to process this team file into the valid zone, I need to start doing some work to make this available to me. So one of the cool things that's available on JSON files, and again, my whole demonstration is focused on tough JSON file ingestion to a data warehouse. I have this Json Viewer that you can see here. So if we need to refer back to it, this is what the teams file. This is a different one that I picked. But this is what the JSON looks like. It's not too incredibly difficult. We can do the expand all. So this isn't a burdensome number of attributes, but I want to flatten this because my users like tables, and my users want to be able to take those tables and perform the fact dimensional analysis to be able to convert that stuff to a data warehouse, which is going to be tabular. So even though it's JSON for ingestion, we want it to be a table invalid in the valid zone, not an invalid table. And that you can use in SQL is called explode. And so what we can do is explode this team's attribute into all its elements. Well, that's much more helpful. Now I've got all those like base level attributes here, and I can scroll across and see them. But then I still have some nested objects. So I've got to work with that. And the syntax for this is to simply grab the copyright column, which is just a straight string, and then I do call.star from the exploded teams. And so this command exposes everything that's in the teams attribute as a call.name of attribute. So we need to start like digging into each of these attributes. And so what we can do is say, okay, let's do call.star and let's do call.division.star because division was one of the loaded elements here. Sorry. You can see division has 3 nested elements. So I want to look at all of those elements. But now when I do it, I'm not going to query just that one file. I'm going to query the whole 2020 directory. So now we're going to get back multiple rows. We're going to get back one row for every team that's in that thing. So even though I'm processing, again, directly to files, I don't have to give it a file name. I can look at all the files in the folder, and Databricks can handle that. So as you scroll to the right, you can see I've got my division ID, link, and name that came back from this division.star command. So that's good. We're getting there. We're getting everything flattened out. But what I don't like about this is that the attributes now cross over. So I've got these other IDs and links, but I've already got an ID and a link in my data set right here. So now I got to handle that as a data engineer. So what I wrote was a much longer query that selects out every attribute and gives it a nice friendly name. So I give it an alias that has the number of like how deep in the JSON it is. And then I'm going to go get every team across every year that's in my data lake. So this is going to explode that out. So this is going to be, I have 4 years worth of teams data. So there's 30 teams in MLB. There's 4 years of team data. So that's 120 rows. So now what I have is a much cooler, fully flattened out version of all that JSON with good attribute namings. And I'm ready to now say, hey, this is a valid data set. I don't need to do more with it, but my analysts are going to go look into it and tell me what they want to do from a DIM and fact perspective. So I need to make this query productionized. So how do we want to do that? We basically could create a view and call it Stats API vteam, and we could create it and then it's good to go. That's not materialized, and so it would be running this query dynamically every time everybody hit it. And so an approach is to create a load notebook that says I'm going to create this table. It's going to be called statsapi.team, and it's going to have this query, and then I want to productionize it. So I see a couple things coming through. Handling embedded JSON arrays. So that is this. And I know this particular example doesn't have it, but I'm going to show you one that does in the next, in the games file. The games file is a lot more complicated. So what I have done historically is built a load notebook for this table, and I'm going to call it season team, because like I was describing, this is 120 rows in this teams folder. It's one record per team per season. So I think that's a better name to call it season team. And you can see here's my query that I showed you, that I built, that I'm really excited about. The syntax in Python allows you to actually make the file path dynamic by saying .format on a query and saying I have this variable FP. I'm going to replace the contents of the curly braces FP in my query with this literal value file path. That file path can be something that I pass into this load notebook. So one of the cool things Databricks makes available to you is the dbutils widgets, which allows you to basically have parameters. So if we say, I want you to load the season team table, I'm going to tell you a single file or a directory that I want you to process. Then I can take that data from the raw zone and put it into a Delta Lake table in the valid zone and materialize it for my analysts to use. So what I've done is create a framework around this load notebook. So a really cool thing that Databricks makes available is the ability to import or run other notebooks. So I created a class library, and it is very extensive. It has all of my reusable methods. It has all my platform constants. So for example, I return back the current user, the name of my platform database. So that's my controller, my engineering database. I just call it platform for lack of a better word. I can get the path of the notebook that I'm running. I can get the Databricks Workspace I'm running. So for logging purposes, I can get the notebook's fully qualified path. I can get the directory of the notebook and then the name of the notebook. So there's a lot of things you can get out of the metadata of it running. And then I've defined a bunch of functions. So this function is called log load step. As you might imagine, this is my logging framework. It takes a bunch of parameters and stores them in a Hive Metastore table in my platform database. So as I'm doing my ETL, I'm writing all of my transactional information, the row counts, the errors, the who did what when to that space. As we go down through some other methods, I've got loading and error. I've got that the step started. So this is managing just, hey, there's method on method here. So the log load error will run the get step start method to decide when that step began. We can get the transaction row count. So one of the other things that Databricks makes available is the describe history of a table. When it is a Delta Lake table, you can actually get all the number of rows and changes and by what was done. It stores all that behind the scenes that you can go access. And so I go grab that stuff and log it in my framework that's a little more built for my needs and my tracking. So I'm actually leveraging something Databricks makes available there. So again, there's just a lot of Python here that we're not going to get too far down, but just know that there's a lot of capabilities as a data engineer and a developer that you can put into these methods, and you put them all in a class library, and then you make your standard ETL or data engineering template import that library. I then say I'm going to start this notebook. I'm going to say my database name is the same as my directory where this thing is stored. So in that sense, my database name is determined by where this file lives. It lives in the Stats API folder. So it's going to create a database called Stats API, and it's going to load a table called season team. So that's, again, just a little more dynamic. I can store my files where they need to be, and that will govern what the databases it's using are. I have my natural key list. So as I'm thinking about doing a merge with this data set, I'm telling it a season and a team's ID represents your natural key to do the merge on. I then log that I'm going to start this notebook. I then have my query that I'm going to execute. So this query loads a load table. I assign the variable query, and then I have this data frame that I'm executing the query into. So this data frame now contains the results of this query. Then I call a method called merge data frame to target. And what that does is goes to my class library and takes the data frame and merges it to the target. So this is the standard way that I say data frame in Python, where it has a certain list of columns and a certain schema. I'm going to merge that to the target. Oh, by the way, at the same time, if that target doesn't exist, I'm going to create it. And oh, by the way, if there's a new column in my data frame that's not in my target, I will add it. And if there's a column in my target that's not available in my data frame, I will ignore it. So that's all perfectly valid in this scenario because the JSON could adjust over time. And so what I want to do is have a nice structure persistent where it's not going to affect my users that I don't populate columns if I don't have, or sorry, that I take away columns, because you don't really do that in a data lake. I'm also making sure I have my audit columns, and I'm also making sure that that I'm doing a merge of the data based on that natural key. So this generate merge query function goes to my library and says, hey, I'd like you to build a merge command for me based on these natural keys and these two things. So it's going to materialize your data frame into a target table. It's going to then do the join of those two tables. It's going to look for a change, and it's going to apply the change for you. And I like the idea of making your functions schema managing like intelligent. So let it manage all that schema for you so that nothing errors out when it loads. So once that's complete, I'm going to validate my table. So I've written rules that say, hey, you need to go through and say that the integrity of the columns is there. Unlike SQL Server, we don't get primary key or unique constraints with data lakes. So I've had to build that kind of stuff under the covers to go check to make sure that none of my merge commands went rogue, and created two versions of a season team combination. And then I logged that my notebook finished. So we can actually just go ahead and run this whole notebook. It's going to go through and it's going to check the stats API season team table for those 120 rows. It's going to look for differences, and it's going to print out all the stuff that it does. So the big takeaway here is that this is a template that we're following a standard format, and there's not that much business logic here. There's nothing really specific about the table other than I've hard coded the name, the keys, and the query. Everything else is pretty abstract out and is just being reused. So as I start adding more tables to this process, all I have to change out is the query, the keys, and the name, and I can reuse everything else here. So you can see dynamically it's coming down here and it's applying this file path that I passed in. So in this scenario that I'm running the notebook for, I only passed it one file from the lake. It actually drops the table _load if it exists, and then it creates it for me, and then it merges into the target table using this. There's a whole much bigger query behind the scenes, but I just print out this command. And then I drop the load table when I'm finished. It's now going out and validating that table, which calls a separate notebook, which I'm getting ahead of myself a little bit, but from Databricks, you can call methods that run other notebooks that exist, and then it'll light it up with a little link here that you can click. And you can see what that notebook is doing. So you're not only running code in cells in your notebook, you're actually asynchronously kicking off other things. But in this situation, it's waiting for it to return before it proceeds. There is a way to just tell Databricks, don't wait, go ahead, run it, and I'll just move on down the cell pattern. So this is just running through some of my other code that goes through and runs all these database validations on that table and logs my stuff to this validation log to say, hey, I validated that table. I think everything looks good. Or, hey, here are the errors that I found. So you can add your configurations of what errors would you like to check for on any table to a configuration file or table, and then check those like every time it loads. So this is where I've built in the ability to do like unit tests that it checks before deploy, or not before deploying code, but before saying the table is productionized and ready to go. So there it finished. So it ran for a little under 2 minutes to load in one file of data into the target. And a lot of that is the validation. So if we wanted to not validate every time, we could speed up our process. But anyway, I'll stop there. That's one approach to data engineering with Databricks with a good framework. So what questions do we have? I've seen a lot of stuff go by. So
there was a question about importing modules. I think you can do that with the repos feature now. It used to not be that easy to do that, just like a standard import. But I think you can do that with repos, that they've allowed you to do that now.
Yeah, so there's the ability to import libraries just at the top. So I do that in my class library so that all my notebooks that import my class library get the availability of those same functions. So all these are available on my platform because I've defined them here. As far as other things, I've put everything that my platform needs in this one class library. So I think you would be able to go navigate to other repos. I'm not sure. So if we look at where you can, within the same repo, you can go across folders by using the double periods. I'm not sure about other repos yet. I guess if you attach them here, you might be able to.
I haven't used it, but according to docs, you can the workspace's repos path is actually in the path now. It's like so you can import from it.
Okay.
So, yeah. BJ says you can go repo to repo. So yeah, that's a pretty cool feature that they've enabled.
Yeah,
with
like this one, you can see that I'm going out. There's just however many periods, I guess, you stick in front here to go all the way out to your repos that you've linked. So yes, you can do that. What else we got?
I think that was it. I think that was all the questions so far.
Okay.
Oh no, there was one from Michael. What would you suggest for handling embedding JSON arrays? Did you see that one already?
I'm gonna do that one now.
Okay.
So any questions on this first approach?
I had one question, Cameron. That the syntax you're using in the SQL side, like with the JSON prefix, I hadn't actually seen that before. Is that a new syntax or?
I'm not sure like when it came out, but I know that you get the ability with the SQL, the Spark SQL language to be able to do JSON dot, and with the backwards tick, CSV dot. I haven't used any other ones than that.
Okay, I've seen that for Delta plenty of times, but I hadn't seen it for JSON. So that's pretty cool.
Yeah, and I like that it, when you get in here, it automatically explodes stuff out. So the last thing I'll say about this is that if you start to get hundreds of tables, that's a lot of notebooks. So one thing I tried to do was say, well, and it also requires that I do this amount of work to find the query that works for me to flatten this JSON. And the minute that the JSON changes, my query breaks. So that's an important thing. And that leads me to the next example, which is a game file from MLB is way bigger than the Teams file was. And I'm going to go and expand this and how long it goes. And this is where you'll see there's embedded. So this is arrays of structures of arrays of structures of arrays of arrays of things that need to be pivoted. Like this thing was a beast to write SQL on top of. So what this, and then, sorry, it's refreshing still. What this game is this Pirates Cardinals game that everything you see on the screen right now is in that JSON. So even the metrics that lead you to be able to create this visual are in the JSON. Every piece of information about a pitch, every piece of information about an at-bat, and not obviously the player's picture, but who it is and what they did and when they did it and the time stamping of all this stuff is all in this JSON that I want to parse out and process. So writing a SQL query that processes this is not scalable and probably just a bad idea because they change the format every so many days. I've actually seen new elements over the course of a season. So what I did was create a more generic load notebook called source dataset to valid. And so this comes in and uses our same library concept. Now we have more parameters because I've said for a given source system, which is the stats API, for a given source data set, for this instance, it's the game file, because that's the one I've picked. That's what this guy is. That I want to, I ask for a partition value because I don't want to do just a specific file path anymore. I want to be able to do all the files within a given partition. And so the file is actually optional here so that I could say process all the games for 7/24/2020. And then table name, I could actually say, hey, go get a specific file, go or get a whole directory and only load one of the tables that I've configured. So we're now going into more abstraction away from knowing the specifics of a given data set. This is going to open up a JSON file, flatten it for me, and then load all the tables that are configured in my reference table that drives this, that says this is how I process my data. So the big change here is we have to get our data set configs and stage the data frame. So I run a query against my platform database called reference data set. And basically just know behind the scenes, I have a bunch of information that I've split out about a data set, the game file, on what I want to do with all the tables. And as I said before, it's not one-to-one with the way that I wanted to use this data. It just granularity-wise didn't work. So that game file I showed, I actually broke it into 14 different tables, and they're all listed here, based on just the complexity of where the arrays lived and how many elements were in that to make it scalable to actually analyze. So I did all the work to figure it out, but I put it all in a configuration table. And then now I'm looping over that configuration table to say, when you give me a file, go dynamically to say, how do I process that file? So then I say, what's the type of my file? It can be a JSON or a CSV or a text. So I process those here to figure out what the type is. I then put into a source dataset data frame everything that's in that file. So I'm basically just grabbing the file or the directory of files, storing it into a data frame, and then I'm looping over all the tables that are configured for that data set. And then I'm going to start processing it. And then let's ignore, for the purposes of this, everything that's in this pivot situation. This is very specific to what MLB data does, but that answers your question about embedded arrays. If you might want to pivot them. One of the things that they do here that I think is really kind of odd, but is a good use case, is they have all the players have their own element within the array. And I don't want those to be separate columns when you do the explode. I want those to be separate rows when I load my data set. So all the players, each one gets its own row, not each ID gets a series of columns, and then it would just be a super wide table. So that's what I did with embedded arrays of JSON, is I pivot them down. And so this knows how to do that. This knows how to go through and say which of the names are pivoted and which ones are not. And that's in my configuration as well. The big method here is called flattened data frame. I was irate that there isn't anything in Python that does this out of the box. And so I had to build my own that knew how to go through a data frame and say, let's loop over every single attribute, dynamically determine what the type is, and process it accordingly. So in the data frame, schema fields and schema data types, in the schema fields, there's a data type and a name attribute. So you can go through and say, once your data frame's loaded from a file, what's the name of all the attributes and what are their data types? If they are structure or array, you can have your thing behave differently. So that's what this is doing right here. So this processes them. And I just went through enough scenarios and testing and figuring it out that I built this function that then returns a completely flattened data frame back to the caller. So now this comes through, it loops over those tables, it dumps everything into that same merge data frame to target method. So that thing that I showed in the last notebook is still relevant, where it took a data frame that was flattened and then still does all the schema management. And then when I'm finished, the notebook ends. So I abstracted out that need for a bunch of different templates for each table that are each query specific. And now I have a really generic method for handling all my data sets, assuming I've configured the tables and how they will behave in my reference data set. So that's how I've approached that problem. And it actually works quite well. It takes about 12 minutes to process a file. So in the fun, exciting world of live demos, I'm going to kick off this notebook as we talk about other things. So this is this is where I want to run. So what I'm going to look at here is just run a quick query against my Stats API game table. And you can see I've loaded 4 games so far out of my data lake. You can see that this game I'm about to do right here, 630989. That's this Pirates game that I mentioned, 630989. So you can see there's actually, it's the same one. It does not appear in this list. This is the primary key of the game. So it's not there today. So I'm going to go ahead and run this notebook. Like I said, we got about 12 minutes for that to finish. So the big close of the presentation is that game is now going to appear in the top row. So I've done some. So let's stop there. That's the loading of data to valid. Again, the takeaway is try to write as much reusable code as you can that isn't data set specific, so that you can handle a bunch of different load scenarios and schema management activities with components in your framework.
Do you use, for your JSON parsing, Cameron, do you use Spark for that, or is that using just like regular Python?
So it's all PySpark as far as my understanding, but it's using Spark SQL expressions behind the scenes in a lot of the places. So if we look here, the working data frame select expression capability allows you to write very SQL flavored things against this. So I actually have a select list that I'm managing. The POS explode method is the ability to do that explode I showed before, but with a position. So that allows me to have a unique entity for all those rows that I'm blasting out. You can do like MD5 hashing. You can do string aggregation with a collect WS function. So there's a lot of capabilities in Spark SQL that you want to get in PySpark, and the way you can do that is with this select expression on a data frame, and then you can also do aliasing and renaming. You can add and remove columns, so you can manipulate your data frames extensively ahead of this process that then puts them into the target merge. So if you can get it to work with, what I found is if you can get it to work with Spark SQL, it's easier to implement it into Python. It's not everything that you can do in Python can you do easily in Spark SQL. All right, so so we've loaded our games up and we are now ready to talk about data warehousing. And so this is where I also was like, oh, well, I'll create a single notebook for my DIM. So I have DIM player. I load my class library. Whoops. I load my class library. I have some variables, table name with my natural key list. I've got my logging. I then do my lookup date range, because good data warehousing will say, hey, when's the last time you loaded? I want to load everything since then that has changed from my source. I've got my query that defines what a player dimension attribute is, and it does it for a time range. So this actually works with a start date and end date input to say, I want you to reload DIMs for the last 5 days, for the last hour, for the last 10 years, whatever the time range is. You can pass them in as parameters. And so this will look for changes at your source. So you can see I've hard coded in my query the season team roster table and the game player table from my Stats API system to get all the attributes I want from my DIM, and then validate the table and finish the notebook. So this is cool. Again, I'm looking at a load notebook for everything. So it's very modular. It's very object-oriented programming to say this is the definition of a DIM player. This is a very template-driven approach. It's perfectly valid and good. I was curious if you could do it dynamically, but now I want basically to create a repository of queries that define these things. And so I created a MLBDW library that defines methods named the same as my tables. So I have a dim game table, which takes a start date and end date. It defines what the natural keys are and what the query is that gets you the game information, and dynamically adds in the date range and then returns those back to the caller. So you can have one notebook that loads all your MLBDW tables. It loads this new library. It has a parameter for which table would you like to run, and still my start date and end date. There is this interesting thing that I don't know how to explain other than Databricks makes available called globals, that it allows you to then say, if I say dim game is a method, I want to take that value of table name that is passed in from my parameter and basically give that value to this load method variable. And then I can call load method with the parameters, start date and end date. That's just like calling the phrase dim game with a start date and end date and returning the values back. So now my notebook is agnostic of what table I'm loading. It's a parameter, but it knows to go to the library to get the definition of what that query is. So long story short, I have one notebook for this. I have one class library for all my tables. You can see here's my fact game batter is defined this way. And so when I want to load my data warehouse, all I do is call this load MLBDW table and I pass it dim team, dim player, dim game, and then I pass it the name of fact game batter. And as long as those table names are defined in my DW class library, it knows how to get the queries, it knows how to do the start date and the end date, it does all the schema management, it does all the check for columns that may exist, it does the proper insertion and the merge, it can reprocess history. And that all works. So that's another approach to this, is that you can define them there. And then when you talk about productionization, all you're ever releasing is this class library of data warehouse queries. So just all you have is, hey, I want to have a new fact table. Click this button, drop in all the information, and release this notebook to prod. The other components and the pipelines that run those components can be pretty reused. You'd have to do something with this too. You could do this part with Data Factory and then release that as in conjunction. It's just a different approach. I actually think this is perfectly valid, but if you change your template and you want to change how the template behaves, you have a lot of artifacts to change. At my last client, we got over 100 tables in our data warehouse, and the minute we wanted to change anything, it was a lot of code refactoring. So I wanted to get away from that and show a different approach. All right, I'm at time at 6:30, so I want to do time for Q&A. I will quickly show you what's at the back end of our slides. It's a lot of what I talked about already, how I divided up my library assets and my data assets. So just things that you should think about that I might have mentioned. They're all like some cliff notes here. At the end, key takeaways about engineering with Databricks, specifically things about its design, how you manage your tables and files, the CI/CD components, and some do's and don'ts that I've come across. And then lastly, just bubbling all the way up, whether you're using Databricks or not, these are important cloud data engineering takeaways that I want to leave you with to be thinking about as you go down this journey. If you're using Synapse, if you're using Snowflake, you should still do things that are listed here and use some of the ideas, hopefully, that I've shared with you tonight. So, like I said, that's going to be in PDF form coming at you. Since this is only an hour presentation, I usually spend a little bit more time on that section, but I thought we were a more technical group, so I wanted to stick with the code side. So that said, what other questions do we have?
Yeah, so Brandon's opened up the mic, so if you want to unmute and ask questions, go ahead.
We can check on my game notebook so I can get my new Pirates Cardinals game in here. 8 minutes, so it like I said, does take about 12. One of the things about the pivot behavior, since you asked about the how to process the arrays, You can see the output here is almost undigestible, but this is what it was, that this array right here of IDs are stored with all their elements. And so it's pivoting these IDs into rows of data into that target table. So when we look at the fact that I'm loading the game home player table, that is configured as a pivot. So when it hits that attribute that it's looking for, it knows to say each of these attributes gets a row in the table. So that was definitely a unique thing that we had to be able to handle for this particular scenario.
Cameron, I had a question. I will say that I think I found my next interview question with munging this API from the MLB stats, because it is quite the monster. But I'm curious about cost compared to other tools. Like, do you find Databricks, do you pay for, you know, some of the eloquence you have here versus another competing product? How do costs fall?
Really good question, really hard question. So all of this is spun up in my CapTech account, and I have a certain amount of budget. So this cluster is super small and super cheap. So when we talked about my 12-minute runtime, it's probably because this cluster is about the size, you know, the capabilities of a 2019 laptop or something. I haven't spent much time developing fully productionized code in Synapse to get a sense of what the cost would be. I think some of these capabilities and workloads could be moved out of Databricks and into Delta Lake from Data Factory, and you could probably have some cost savings there by manipulating the Parquet files without a compute engine. I just think as a developer and the business requirements that are typically necessary to make one of these things fully functional and stable, it's really good to use the cluster side. So you're going to have to pay for that. I think Synapse may end up in the long run giving you some cost cheaper because it's Microsoft and they have to outsource some of this cost to Databricks. But that said, I've never seen an organization not struggle with cost throughout the Azure cloud. It's never really been, well, we're using Databricks, it's way too expensive, we should switch to Synapse, it'll be way cheaper. I think it's very comparable. Every client I have that's talking about Snowflake is already moving off because they're getting killed on the price. So consulting answer, it depends. I can say you can do a lot of experimentation and analysis on a really cheap cluster that your organization probably won't even notice. It's when you're talking about huge workloads and actual machine learning processes and big data analytics that are more than just a game of baseball data. So developing it, it's cheaper. Production-wise, you're going to have a lot more cost. Our notebook finished. I'm going to do my final query here to show you that our last game hopefully showed up. So it did. There's the top one, or sorry, we got 5 now. It's this one. So that extra game showed up. And now if I processed my data warehouse, it would go say, hey, I have a new dim game. I have new members of a team. I have a new fact that I'll go ahead and load. So we can kick that off too if we want, but. So I don't have a great answer on cost other than this is a really good tool for doing productionized data engineering.
Very cool.
Learn your Python. I avoided it for a long time.
You were doing some Python metaprogramming there at the end, Cameron, that using the globals.
Yeah, I was like, this would be cool if it let you do that. And I was like, yeah, it does.
Yeah.
Well, thank you very much for having me back. I will, like I said, get the slides over to David. And if you guys have if you folks have any other questions, please feel free to reach out.
We'll post the recording as well for those that couldn't make it, or if you want to watch it again. And yeah, thanks, Cameron, for coming back, and glad that we could get this rescheduled. So
yeah,
it's been very good.
Y'all have a good rest of the night.
Thanks, everyone.